derivative. Let's say we find the derivative using first principle for the function. Let's say my f of x, and I'll change the color so that it's not. Let's say now my f of x is 3x squared. Okay, and I say, okay, can you find the derivative of this function? First principle. So what will you do? First principle says f of x plus h. Probably I'll make it easier for my calculation. I'll say 3x. That's it. So I'll say f of x plus h. So Romel, be with me, okay? F of x plus h means 3 times x plus h. I replace x with whatever's there in the bracket. Aishka, you with me?
Yeah.
F of x is 3x over h. And I say limit h tends to 0. Solve it. What do you get? 3x plus 3h minus 3x over h, limit h tends to 0. Yes, Chris?
Yep.
Algebraical, I can knock it off. And I say limit h tends to 0. Yes, Romel? 3h over h. Sorry for the handwriting. Now I apply the limit. I say, okay, let me plug h equals to 0. It's approaching means almost 0, right? So h cancels basically. So what do you left with? You say limit h tends to 0, 3. There's no h here, so I can take this off. So the answer is 3. And what does differentiation, the straightaway formula of differentiation tells me? It tells me if I want to find dy by dx of anything of x raised to the power n, what do? I get this power down and I say x minus n minus 1. So if my x was 3x, so 3 is taken out, x has a power of 1. I take this 1 down, I say 3 times 1, x 1 minus 1 is 0. So 3 times 1, x raised to the power 0, this is 1, so this is 3. Exactly, we got the same answer. Yes, Chris?
Yep.
This is first principle application. You try to find the formula and find the derivative. So exam can ask you, if you use first principle, then you need to use this. And if it is direct derivative, this is the easiest way to do it.
There's also a new one that they told us called central point.
The bisection method.
It's called like the central point of differentiation or something.
You use the Excel sheet to find the central point, is it? No.
No, it's a different formula, and our textbook didn't have this one.
Don't worry about it.
It's really confusing.
This is what it is. You have to stick to this. That's it. Oh, good. Now, let's warm our hands now, right? So I'm just taking this off now. Find the differential, please, quick. Shall I take this off, please?
Yep.
Yeah.
If anyone wants a water or a tea or a coffee, is welcome to step out, but you might lose on what we're talking. So I'll say d by dx of, let's say I'll pick something which I can easily, 6x cube minus 4x squared. 6x cube minus 4x squared. Quick. This is a square. Go for it. Alright, let's expand this out, please. Tell me.
So the first part is 40 squared
Good job.
minus 40 plus 1.
Minus 40
4
2ab, yeah, correct. Plus 1, good.
Yeah.
Did you know, guys, what he's done?
Yeah.
He's applied, Aishka, a plus a minus b whole square. A square minus 2ab plus b square has to be done first. No chain rules, please. You can do it by chain rule as well. That's a good thought. but then we'll do it later, right? Now, tell me. So now, Chris, then where the hell have you gone wrong then? Tell me, what next?
I multiplied everything by t.
Alright, 4t cubed minus 4t squared plus t. Then, what did you do?
I multiplied everything by 2.
So, read me through. What have you done next? What should I write?
Plus 8t squared.
Plus 8t squared
Minus 8t.
minus 8t
Plus 2.
plus 2. Yeah, you're fine until this point.
Yeah.
Then, what did you do next?
I cancelled out common terms.
What are the common terms? Let me know.
Minus 4t squared plus 8t squared.
Is how much?
4t squared.
Plus or minus?
Plus. Oh, minus.
Come on, plus.
Plus.
And what about this one?
That's its own.
Aishka, are you getting it? Romel, are you getting it?
Yeah.
Basic algebra. Then what? So you've done this. What else?
Plus t minus 8t.
Which is?
Minus 7t.
Good job.
Plus 2.
Awesome. Then, what's the final answer now? Now you find the d by dt of this whole term. Then, tell me, what will you do first? Here, Romel, what will you do this one?
12t squared.
12t squared. Good job. Aishka, what about the next one?
Plus 8t.
Plus 8t. Chris, next one?
Minus 7.
Plus 0. That's the answer. You didn't tell me this answer. What was it? Whenever you see something, two numbers, two terms with a plus or minus in the bracket with a square on top, you need to use either this or this. Please, for God's sake. You know differential, but you don't know this. It's gone for a toss. They want to see this. So, Chris, if you would have gone wrong at the end point, if there's a 3-mark question, you'll still get 2. Right? Okay? Every step counts. All good?
Yeah.
100%?
Yeah.
Alright. Now, let's do a question. Can we quickly go to question number, go to 9b please, 9b. Show me 9b, quick, 9b. And I think this question is question number 8 in this book or not? Yeah. Question number 8, 9b. Over to you. Think about it. I need to know part A. How will you do part A?
Yeah. Find the coordinates of.
So it's written tangent 45. Tangent 45 from a circular perspective is tan 45 degrees. What is tan 45 degrees?
Root 2 on 2.
Equals to tan 45 is 1.
Oh.
The value of tan 45 is 1. But what is tangent? Tangent is rise over run, no? If you look at the right angle triangle, everything is connected. And let's say this is right, and this is theta, and this is like 5, 3, 4, 5 degrees. What is tan 45 degrees?
Root 2 on 2.
Equals to tan 45 is 1.
Oh.
The value of tan 45 is 1. But what is tangent? Tangent is rise over run, no? If you look at the right angle triangle, everything is connected. And let's say this is right, and this is theta, and this is like 5, 3, 4. So if I ask you what is tan theta? What is tan theta? Is it not 3 over 4? Yes or no?
Yep.
Soka toa. opposite over adjacent. What is opposite? What is adjacent? 3 over 5. So 3 over 5, what is this? Is this not rise? Is this not run? The y-axis and the x-axis. So another point that we have learned today, the derivative. We've learned so many things on derivative. Derivative is the slope, derivative is the rate of change, it's the instantaneous rate of change, y2 minus y1 over x2 minus x1, da 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 da. One more thing, what a derivative is, the tangent, the tan of circular function. And whatever angles given to you will actually give you the value of the derivative. So here, the tangent is at 45 degrees. So that means if your curve is like this and you're making a tangent here, this tangent is at this point, the tangent is basically 45 degrees to the horizontal. Which actually means the derivative at this point, dy by dx, is tan 45, which is 1. So dy by dx is 1. The derivative is 1. Right? Can you progress further? So if your dy by dx is 1, what is the function given to you? What is f of x? Can you find the dy by dx of the function? How much would that be, Romel?
4x minus 3.
4x minus 3, right? Ayushka?
4x.
Minus 3, come on, f of x is what? What is your f of x?
I got 6x minus 3. It's cubed, right? Squared. Large squared.
2x squared minus 4x plus 1. Come on now, don't let me do that, okay? 2x squared minus 4x plus 1. 4x minus, what? This is 3 or what? This was 3, is it?
Yeah.
So 4x minus 3. And this derivative is 1. Can I solve for x? Can I? So what is x? X equals to 1. Yes or no?
Yeah.
So once you've got x, what am I after in this question? What am I asked to solve?
Find the point at which
This tangent is 45. So basically I'm asked I'm for this point. So found 1. What is my other point? How will I find the y value?
you input 1 into the original equation.
Yes. Ayushka, did you get it?
Yeah.
Yeah? So you put 1 into the original here, you get the value of y, whatever that is, right? That is what? I mean, it's 7. 1 comma 7. Expect a bare minimum of this kind of understanding from the questions. No one will just give you, a child's play like find the derivative of 2x squared. So what we've learned, Romeo, is that when you're given the angle, and he's asking you all these things, find the tangent to da 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 da. Whenever the angle is given in the calculus, especially when you're doing the differential, straight away apply tan of that angle, that will give you the dy by dx value. And then you can go from there. Yes?
Yeah.
Yeah? Now, read part B, Romel. Tell me what, all of you, read part B now. Tell me what it is. I need to listen.
It's parallel to the line y equals 2x plus 8. So make it equal to each other.
What question are we doing?
Part B. The same question, part B.
Question 8.
Question 8. You read this.
Oh,
Now we're doing part B. Read part B now. Tell me what we will do in that. Quick, you're more or less there. Read it again. Let me know what it is.
Don't you just equal to each other? Isn't it?
Equals to each other, as in?
Like 4x minus 3 equals 2x plus 8. Then you get x. Then you sub that in the original.
What's the line which this is parallel to? So what's the line? Can you just read me through the line? Is it asking for a line or what?
Y equals 2x plus 8.
Yeah, y equals to y equals to 2x plus 8. So we're saying that this line is parallel to this line, or what? What are we saying in the question? We're saying
At which the tangent line is
the
parallel.
tangent line is parallel to another line. So this tangent line is actually parallel to another line, Aishka, here, to another line like this. So they are parallel. And the other line is what? 2x plus 8. Y equals to. So what do we do now?
Find the derivative.
Derivative of what?
2x plus 8.
What is the, whenever you think of parallel lines, what should be the first thing that should come to your mind?
Same gradient.
Awesome. What's the gradient of this line?
2.
Good job. What's the gradient of this line?
4.
That's the gradient. No, gradient was what? The derivative. So can I say 4x minus 3 equals to 2? I've just equated the gradients, the two equations. The gradient of this curve is the derivative, which is this one line, and this is parallel to this, so the gradient of this line is 2. These two lines are gradient is 2, and hence I equate them. Yeah, and I find x, and then I plug the x back here, find y. That's it. That's what it is. Yep.
Yep.
Does that make sense, Avishka?
Yeah.
Has it cleared some mud from last year? Yes? Oh, good. Cool. Alright, I will stop here today. So what I've done is that I've covered the basics, 9A, 9B. I've covered a lot when we talked about the stationary